Okay, so looking at adding fractions, tell me what the first answer is going to be. Yes. Okay, and what is the rule of thumb here when you're adding fractions? Just looking at that first one. Why don't...
Fractions when they have common denominators.
Okay, but how did you get 9/10 is my question. Why not 9/20? Why didn't you get 9/20?
Because the denominators stay the same.
So the denominators stay the same. You just add the numerators. So that first one is 9/10. Okay, as we add in variables in chapter 9, you're going to see this same process. We're talking about the process of adding, subtracting, multiplying, and dividing fractions. So on this next one, what do we have to do before we can add them together?
Multiply the denominator on the first column by 2.
Okay.
No, the whole thing by 2.
So what do you mean the whole thing by 2? Like another 2?
Yeah.
Okay. So this is really this problem, which would be, as you told me, you only add the numerators. 11/10 for that one then. Yes?
Would you simplify it so like 1/10?
We're not going to change it over to a mixed fraction in this chapter. No, good question. So we're going to keep them all as improper fractions, number over number. Okay, let's look at these two examples. So you told me we need a common denominator. What should I do on this one? Okay. Okay, which gives you what? So again, getting a common denominator. What happens on this one right here? Yes.
Times the 1/8 by 3 whole column, so 4 3/3 by 8.
All right. Are there questions on this yet? This is what most of you are probably used to doing. I'm going to change things up a little bit, not to something that you've never seen before, but I'm going to change the way that you're showing your work. Okay, because it's going to help us when we add in those variables next week. Okay, so before we do that, let's review prime factorization. Okay, now you can do factor trees. They tend to take up a lot of room on your papers, so I prefer the method where we just use our calculator and start dividing out numbers. So here's what I mean by that. 210, we know we can divide by what? 2. You always start with the smallest number possible. Okay, so we can take 210, so that's what you're going to do, 210 divided by 2. Now the number that comes up on your calculator is 105. Can we divide this by 2? No, so we look at the next number. Can we divide it by 3?
Yes.
How do you know you can divide this by 3? How do you know 105 is divisible by 3? Correct. 1 plus 0 plus 5 is 6, and 6 is divisible by 3, so we know we can divide this number by 3. So we write 3 for our next number. So we divide that by 3, and we get 35. What's the next number that we could divide out? A 5, which would leave you with 7. Okay, so the prime factorization of 210 is 2 times 3 times 5 times 7. Let's jump down here to 360. We can divide this by 2. Can we divide the next one by 2? Which is 180. So there's another 2. Divide it by 2 again. And then what's the next number? Can we divide it by 3? That would be the next biggest number. That is divisible by 3, so we divide it by 3. And then you're left with 5 at the end. Okay, if you're not able to do all the division in your head, use your calculator each time. So let's look at 825. Can we divide that by 2?
No,
Divided by 3?
no.
Yeah.
Why can you divide this by 3? 8 plus 2 plus 5 is 15. You can divide that by 3. So 3 is your first one. So we do 825 divided by 3 in your calculator. We get 275. Can we divide that by 3?
No.
No. Okay, what should we divide it by? 5 would be the next one. We're left with 55. So that would be 5 and 11. Again, if you want to do factor trees, I'm not going to tell you you can't. They just take up more room on your paper. Divide this one by 2. Can we divide the next one by 2? Okay, divide it by 2 again. What should we divide this one by? Can't we divide it by 3? 945. Okay, so we divide it by 3. Another 3. Another 3. And then 5 and 7. Questions?
Do we have to put parentheses in between all of them like that?
It will help you when we get to a couple slides ahead. Yes. Questions? Yes.
They have to be in order.
They don't have to be in order, but the answer key is going to be in order, so you'll be able to match it up with mine a little bit faster if they are. But it's not wrong if they're not in numerical order. Other questions? All right, so let's use this idea to go back and redo these problems the way that I want to see them on the homework. So we already did these problems, but we're concerned about getting common denominators. So looking at the denominators, we want to make them into prime factors. So we can divide this by 2, which would give us 12. Can we divide 12 by 2? Can we divide 6 by 2? And you're left with 3. Okay, so 24 is 2 times 2 times 2 times 3. What do we have over here? 2, 3. Now, how could we make them look exactly the same? What does the one on the right need? 2 more 2's. Now, when we did this problem originally, multiplied that fraction by 4 and 4 on the top and the bottom, which is where the 2 and the 2 and the 2 and the 2 are coming from. This is showing the work that I need to see because this is the process we're going to be using when we add in our x, y's, and z's next week. So right here, this would be the next step of work. 5 times 2 times 2. So we end up with the same answer, obviously. We're just showing our work a little bit differently. This is the most important part of the worksheet that I'm going to be looking for that all of you can do, because this is what we'll need to do when we add in our variables in Chapter 9. All right, so looking at this one, the work that I would need to see, 3 can't be broken down anymore. But 8 can. We only worry about the denominators when we're adding and subtracting. Good question, though. All right, so this one is going to need all of those 2's. And this one only needs that 3. Now there will be cases, and they're going to come up in the next page here, where we don't have to use absolutely everything from each side, and we only multiply by maybe a couple of numbers to make them match, which is going to really benefit us when we have x, y's, and z's involved so that our problems don't become enormous and then we're foiling a bunch of things over and over and over again. Okay, we want to multiply each side by the least number of items as possible. So we've got this as our next step. So again, the work step is the part where it's different. Okay, this is not what we did on the first page. This is what I'm going to be looking for.
We can't do what we did on the first page.
Cannot do what you did on the first page, no. So let's try 2 more examples on the next page. Brand new problems showing the prime factorization in the denominator. So this would be an example of what I would give you on the homework today. So we don't have to worry about prime factorization with the numerator, but on the bottom, what do we get here? 2355. All right, what about this one? 223. Now we want them to look the same. So on the left, what do we need to add to the top and the bottom? And multiply the top and the bottom by?
3 or 2.
We're just missing a 2 over here. What about on the right?
2 5s.
Mm-hmm. So we change it over to be the numbers that they are when we multiply them, and then we can add them together. Now I'm not going to worry about you simplifying your final answer. My answers on the worksheet are not going to be reduced or simplified in any way. I'm really looking at this process right here where you've got the prime factors. Let's try another one.
We can't do anything over here.
What do you mean?
Well, you can add 5 and 6 times out the other.
What do you mean?
Like we're doing before. Divide it. 5 and 6, you can't divide it.
56 divided by 2.
Oh, yeah, like that.
So is this the proper prime factorization over here?
Yes.
Okay, what about 20?
2 to 5.
225. All right, let's make them look the same. What's the one on the left need? Just a 5? What does this one need?
7.
Okay, help me out with these bigger numbers here. What are the top numbers?
20, 15.
And this one? Okay, which gives us
23.
any questions? Should we do one more example, or do you understand the process?
Understand this?
We understand? Okay, then we'll skip the next slide, because that was just one more practice problem. And we'll look at multiplying and dividing, which is actually a lot easier. Why is it easier to multiply and divide
You
fractions?
don't have the same denominator.
Correct. So when we multiply fractions, how do you do it? Tell me the process.
Set up the dot product.
So we were going to skip that next slide. That's if you have equal fractions, you cross multiply. Yes. Yes, you multiply both numerators straight across, multiply both denominators straight across. Now we need to do prime factorization first because we get to cancel out a lot of things if they match. So let's do that. Now we want to do both the top and the bottom.
So we do have to simplify for this one.
Yep, these ones are going to be simplified when we're done.
Prime factorization.
Yep.
I know. I'm asking when you have the option to sign it in 2 days. So I didn't know if we were simplifying or not.
What about 30? 2, 3, 5, and 63.
337.
Now, you told me that we multiply straight across the top and then multiply straight across the bottom. So essentially, we can think of this as one big fraction. So everything on the top is together and everything on the bottom is together. Now we get to cancel out anything that matches on the top and the bottom. The reason we use parentheses is because when we add in the variables, anything inside a parenthesis, if it matches on the bottom with parenthesis on the inside, we get to totally get rid of it. So what goes away? 3 and 3. 3 and 3.
2.
The top and bottom.
We need one on the top and one on the bottom. There's another number we can get rid of.
5.
Okay, there's a 5 here and a 5 here.
But the fractions are together, so then you can't do the cross.
No, they are all together. So everything is on the top. Imagine squishing them all together into one. Anything else? Okay, so what's our answer? 8/21. Okay, what do we do when we divide by a fraction?
You don't have to. You divide it out equally.
What's the process, though? There's a routine that you follow.
Prime factorization.
Well, we do prime factorization, but what do we have to do when we divide by a fraction? There's something you do with the second fraction. You flip it. Okay, so we multiply by the reciprocal. So anytime you see a division, you have to flip the second fraction to its reciprocal. So let's do the prime factorization here. We've got 2, 2, 3. We have 5, 7. Now we're going to multiply by what?
5, 3.
We have to get that reciprocal on the second fraction.
You cancel out on these though?
We still cancel out, yes. So we imagine that this is all one big happy family here. So what goes away? The 5s are gone. 3s are gone. We are left with 4/7.
Why can't you just divide right away if you knew that it's divided out equally? Instead of showing the prime factorization where it came up with it's divided out equally right away.
Because this is, the reason we do prime factors is because it's going to help us next week. Just getting us used to the process.
Can't you just divide straight across because
Not always. Doesn't always work out evenly. This one? Do we flip anything?
No.
No. So we're just going to multiply straight across with our prime factors. All right.
11.
3s are gone.
2s
2s
are gone.
are gone. 11s are gone. Over what? Any questions on multiplying and dividing? Just to recap this before we do the last slide, which is something different. Multiplying and dividing, you do prime factors on top and bottom. When you add and subtract, you're only concerned about the denominators, so you don't need to prime factor the numerators when you add and subtract. Just when you multiply and divide, so you can do all the canceling. We don't do any canceling with adding and subtracting. All right, last thing to talk about is changing a mixed fraction into an improper fraction. Again, this is review from elementary school, but somebody tell me the process. Don't tell me the answer. What is the process?
Multiply the 5 times 3 and then add it.
Okay, so we're going to take 5 times 3, and then we're going to add 2 and put it over 3. Okay, so in this case, it would be
17.
all right, so knowing that, let's answer one more question, and then we'll be ready for homework. So we need to switch both of these to be improper instead of mixed fractions. So this would be 10 over 3 divided by, okay, so let's do prime factors here. We've got 2, 5, 3, and then we're going to multiply by what?
7 over 20. 7 over 2, 5, 2. 2, 2, 5.
Okay, we always do the reciprocal if we're dividing on the second one, so that's why we flipped it. So now what goes away? 2 goes away, 5 goes away, 7 over 6. Any questions? Again, the process is what I'm looking at.